Let us consider a curve whose equation is given by the vector r, which is a function of time t. Now, we need to determine the magnitude of the tangential components of its acceleration at time t equals to 2. Let's suppose that a particle is moving along this curve and we consider a particular position along the curve which corresponds to the time t equals to 2. So that means, let's say, this is the position vector of that particular point calculated at time t equals to 2. Now, what will be the tangent to this curve at that particular point? So we draw a tangent which passes through that particular point and touches the curve at the point P. Now, the tangent is given by the rate of change of the radius vector r, which will be calculated at time t equals to 2. This is also referred to as the tangent function, but our task will be here to determine the tangential component of the acceleration at that particular point P. So let us begin. So here we are provided with our equation of the radius vector, which is given by t cubed minus 4t I cap plus t squared plus 4t j cap plus 8t squared minus 3t cubed k cap. Now what we'll do, to find out the tangential vector, all we have to do is take its derivative with respect to time t. So this is also the velocity vector, which will be a function of time t, and also referred to as the tangential vector, which is a function of time t. So this will be simply take the derivative of each of the components of I, j and k with respect to time t. So we'll get 3t squared minus 4 times I cap plus 2t plus 4 j cap plus 16t minus 9t squared k cap. Right. So this is our tangential vector or the velocity vector. And then if we take its derivative again with respect to time t, then this was going to give us the acceleration. That means we are taking the derivative of dr over dt with respect to time t. So we get the second derivative. So this will be simply taking the derivative of each of the components of I, j and k of the velocity vector. So we will have 6t I cap plus 2 j cap plus 16 minus 18t k cap. Now let's label all of them as equation number 1, 2 and 3. And what we'll do, we'll calculate each of this vector at a particular time, which is the time t equals to 2. So we'll begin with our tangential vector. So at the time t equals to 2, so this will be simply substitute the value of t with 2. So we have 3 times 2 squared, so that's 4 times 12 minus 8. So 12 minus 4, not 8, 12 minus 4 I cap. Plus we have 2 times 2, so that's 4, 4 plus 4, so that will be 8 j cap. Plus 16 times 2, so that's 32, minus t squared, so that will be 4. 4 times 9 is 36 k cap. So that means our tangential vector will be 8 I cap plus 8 j cap minus 4 k cap. Let's label this as equation number 4. This is the tangential vector calculated at time t equals to 2. Now, we can also define the unit vector of this tangential vector at that particular point 2. So that is simply defined by the tangential vector calculated 2 divided by its magnitude. So that means we have the vector 8 I cap plus 8 j cap minus 4 k cap divided by its magnitude, which is square root of 8 squared plus 8 squared plus negative 4 squared. So when we compute this value, so this is equals to 12. So that means we have 2 over 3 I cap plus 2 over 3 j cap minus 1/3 k cap. So this is our unit tangential vector or the direction of the tangent. Right. Now, we have been asked to find out the magnitude of the tangential components of its acceleration. That simply means to find out the magnitude of the tangential components of the acceleration, all we have to do is take the acceleration vector, which is computed at that particular time, t equals to 2, and we take its dot product with the unit tangential vector at that particular point. So this will be equals to, so our acceleration vector, we also need to calculate our acceleration vector, so we'll use equation number 3. So let's do that here as well. So our acceleration vector calculated at t equals to 2. So this is 6 times 2. So we have 12i cap plus 2j cap. Then we have 16 minus 18 times 2. So that is going to give us negative 20k cap. So that means our acceleration vector 12i cap plus 2j cap minus 20k cap. So this is going to be dotted with the tangential vector, that the unit tangential vector. So that's 2/3 I cap plus 2/3 j cap minus 1/3 k cap. So that's equals to, so we have 12 times 2/3, so that's 24 over 3 plus 2 times 2/3, so that's 4/3 plus 20 over 1/3, so that's 20 over 3. So this is going to give us 48 over 3. So 48 over 3 is 16. So this is going to be the magnitude of the tangential component of the acceleration at that particular time, which is t equals to 2.